Chemical reaction. Chemical reaction is nothing but when two or more substances combine to form a new substance whose chemical and physical properties are completely different from the original substance. Okay, examples are fireworks and rusting, ripening of fruits, photosynthesis, and respiration. When the chemical reaction takes place, there will be change in state, that is from solid to liquid and liquid to gas. There will be change in color. You can notice in ripening of fruits, there will be change in color. There will be change in temperature, as chemical reactions are two types, exothermic or endothermic. When the fire explosion takes place, there will be release of energy, so there will be change in temperature. Okay, endothermic reaction means there will be absorption of energy. Exothermic reaction will be there is a release of energy. There will be evolution of gas. For example, if the paper burns with an oxygen, paper is a carbon compound, it burns, will give you carbon dioxide gas, so there will be evolution of gas. All these chemical reactions can be written in the form of equations. So this is nothing but a symbolic representation of a chemical reaction, where reactants are written on the left hand side of the arrow and products are written on the right hand side of the arrow. Let us write the chemical equation here. You have magnesium and oxygen combines to give you magnesium oxide, MgO. Magnesium, just note down, magnesium and oxygen will give you magnesium oxide, MgO. This is an equation written in the formula, that is you can write the word equation also. You can write magnesium plus oxygen will give you magnesium oxide. Okay, magnesium oxide. This is a word equation, but if you write the formula symbols, then it is called symbolic equation. This is a symbolic equation where it is a word equation. Okay, here this is called reactant and this is called product. This is called reactants. The left hand side of the arrow, whatever you have is reactants, and right hand side the arrow, whatever you have is products. Okay, it is reactant and products. Okay, this. Now here magnesium is reactant and oxygen is reactant. Magnesium oxide is a product. Okay, let us take one more example. Carbon combines with oxygen and gives you carbon dioxide gas. Here we can specify the state of the reactant as well as product. Here carbon is a solid state, oxygen is a gas state, and carbon dioxide is a gas state. Okay, in a chemical reaction we can specify the states also. Here the reactants are carbon and oxygen and product is carbon dioxide. Now let us take one more example. Iron combines with the zinc sulfate and gives you iron sulfate and zinc. Here the reactants are iron and the zinc sulfate, and the products are iron sulfate and zinc. Let us take one more example. This is a familiar example. This is a photosynthesis example. Okay, photosynthesis reaction. In this, carbon dioxide combines with the water with the help of sunlight and chlorophyll. With the help of sunlight and chlorophyll, gives you glucose, oxygen, and water. Okay. In this reaction, we have specified sunlight and chlorophyll. Sometimes temperature, pressure, and catalyst can be expressed above and below the arrow. Okay. Temperature, pressure, and catalyst are expressed above and below the arrow marks. Okay. All these equations should be balanced. The balancing chemical reaction is nothing but number of atoms of each element on the reactant side is equal to the number of atoms each element on the product side. Let us study the balancing chemical equation with an example. Let us take an example. Balancing chemical equation is according to the law of conservation of mass. Okay, zinc plus sulfuric acid will give you zinc sulfate plus H2 gas, hydrogen gas is evolved here. So this hydrogen gas evolution you can say like in this way, that is it is an upper arrow. Okay, zinc plus sulfuric acid will give you zinc sulfate plus hydrogen gas. Let us note down the element in the left hand side, reactant side, that is Z, zinc and hydrogen and sulfur, and you have oxygen. Same element are there in the right hand side also, right? Let it write down the atoms, number of atoms of each element. Zn, you have 1 in the reactant side. H2, so 2 in the reactant side. You have sulfur, you have 1 in the reactant side. Oxygen, you have 4 in the reactant side, right? Zn1, H2, so hydrogen is 2 here. Sulfur is 1, oxygen is 4. Now let us go to the product side. Zn, here again you have 1 in the product side. Sulfur, you have 1 in the product side. Oxygen, you have 4 in the product side. Similarly, hydrogen, you have 2 in the product side. See, you can see here 1 reactant side and product side, they have same number of atoms of Zn. Similarly, hydrogen, similarly sulfur, similarly oxygen. It is balanced. That is, we don't have to balance, it's already balanced. Okay. Here we have hydrogen combines with oxygen will give you what? Okay, let us write the element. Hydrogen combined elements are hydrogen and oxygen. In the product side also you have hydrogen and oxygen here. Okay, now see how many hydrogen in the reactant side. It is 2 hydrogen. You can see here 2 hydrogen. Similarly, how many hydrogen in the product side? You can see how many hydrogen in the product reactant side. Sorry, how many oxygen in the reactant side? It is also 2 here. This is 2 and this is also 2, right? H2O2, correct? H2O in the product side will say H2, that is H is 2 and O is how much? O is your 1O. Okay, now how will you balance it? Okay, this is balanced? No, this is not balanced, because this is balanced but this is not balanced. That is O, you have reactant 2, in the product side you have 1. So what we'll do is, to make it O2, we will add 2 here. We'll add 2 here now. I'm adding 2 here. Okay. No, I can't use this pen, so I'm going with this pen only now. No, I can't use that pen also. I don't know what happened to that. Okay, now I'm using. Yes, now it is working. Now see, let us see here. I'm adding 2. As I added 2, now this becomes 2O. See, this becomes 2O. This is 2 now. This is 2 now. We'll cut and write down 2. But what about H? H has also changed. 2 into 2, H is now become 4. 2 into 2 is how much now? It is 4. In the product side, the value of H is changed. Now it is 4. Okay. But in the reactant side, we have only H2. So how to make this 4? Just can add here. This becomes 2 into 2. 2 into 2, 4. So you can say here, excuse me, the H has become 4 now. Okay, here 2 into 2, 4, and the product side also 2 into 2, 4. And O is already 2 in the reactant side, and the product side O is 2 here, 2O. This indicates, this 2 is indicated for both this and this. Okay, 2 into 2O. This is 2. So now it is balanced 4, 4 and 2, 2. Thank you. Let us take one more example. Methane combines with oxygen will give you carbon dioxide and water. Okay, it's a burning of a natural gas process. Okay, now let us note down the elements here. We have C, carbon, you have hydrogen, you have oxygen. Carbon, hydrogen and oxygen. Let's see the reactant side. That is the reactant side. What is element of carbon? How many element of carbon? 1 element of carbon, 1 C. 4 H is how much? 4 H is 4 here. Okay, similarly O is how much? 2 into 2. How much it is? O is also 4. This is 2 2s are 4. Remember, let's see in the product side. Product side carbon is 1. You have 1 carbon. O is how much? 2 here and 1 here. O is 3 here. And H is how much? 2 here. H is 2. H2. 2. H2. O is 3. Note down O. Here O is 2 here and 1 here. It is total 3. Okay. Is this equation balanced? No, this is balanced. Okay, happy. This is no, not balanced, and this is not balanced. Now how do we balance it? Now in the reactant side you have 4, here you have 2. Okay, now I will add 2 here because it is an even number. As 2 2s, I'll make it is 4. I'll make it 4. Now H has become 4. H has become 4 in the product side, but because of making H4, the O is also become now increased here. Increase O is now, previously it was 3, now it is 2O plus O2. 2 plus 2 is how much? 4. O has become now 4. Clearly see here, it is 2O. This 2 will be added to this also. 2O plus O2. 2 plus 2 it become 4. Okay, now this become both. Now it is 1 1 balanced, 1 1 balanced, 1 1 balanced. Finally it is balanced. Okay, let's see some complex examples now. Let us take one more example. Here we have hydrogen nitric acid combines with calcium hydroxide, gives you calcium nitrate and water. I repeat, nitric acid, HNO3 is the nitric acid, calcium hydroxide gives you calcium nitrate and water. Let us note down the elements here. We have hydrogen here, nitrogen here, oxygen here and calcium here. Okay, 4 elements. Let's note down the how many atoms are there. 1 plus 2, that is H2 here. So it is 2, it is considered as 2. It is O2 as well as H2. So it is OH2 means what? O2 as well as H2. So H2 here plus 1 here, H, total 3. Okay, I repeat, H2 here plus H here, 3. 2 plus 1, 3. Now nitrogen is 1 here. So only 1 nitrogen. Oxygen you can see here O3 here, 3 plus O2 here, O2 as well as O3, 2 plus 3 is how much? 5. Okay, it is 3 here and 2 here, 2 plus 3 plus 2, 5. Calcium is 1 here. Okay, now the product side we'll see. In product side we can see that hydrogen is 2 here, that is H2. Okay, nitrogen is 2 here, sorry, N2, this bracket, outside the bracket you have 2 suffix, means it is 2, N2, 2 it is 2. Okay, what is written here? 2, it is 1 now. Similarly oxygen, here 3 2s are 6, see 3 2s are 6 plus 1, 7. Okay, oxygen is how much? 3 2s are 6 plus 1, 7. Calcium is how much here? 1. Okay, now how to solve this? See, this is balanced? No, it's not balanced. Now we have to balance. First let us start with H. Here 3 here, here 2 here. Which is the nearest prime number? Nearest even number, it is 4. Let us make this an even number 4. See, what I will do is here 2, so I will just add 2 over here. We'll just add a 2 over here, 2H2. I'll make it as a 2H2. 2H2. Now 2 2s are 4. It becomes 4. How much? 2 2s are 4, it becomes 4. Okay, now here what I will do, I will already 2 here, so I will just add 2 here, so it becomes 4. 2H and H2, it becomes 4. H is balanced. See here, 2H and H2, and here 4, and similarly here 2 2s are 4. H is balanced now, but H is balanced, rest of the thing is unbalanced now again. See here, now N, previously it was 1 here, now it become 2 here, 2N. How much it is? 2N. N is 2 now. What about here? Let us see here. It is N is 2, N2. Oh, this is also balanced. Very good. N is 2, N is 2 here. Okay, we'll see O. O, previously it is 5 now. Let us see how much it is. 2 3s are 6. 2 3s are how much? 6. Plus O2. 6 plus 2. It is how much? 8 here. See here, I repeat, 2 3s are 6, O2, that is O2, 6 plus 2 is 8 here. We'll see here now, 3 2s are 6 plus 2, this 2, can you see this 2 here? This is valid for this H also. Oh, so 2 plus 6, total it is 8 here. So this is 8. Wow, this is also balanced now. Now it's calcium. Calcium is 1 here. Here also calcium is 1. So now your equation is balanced. Let us see the different type of chemical reaction. They are combination reaction, decomposition reaction, displacement reaction and double displacement reaction. Let us see the first one, combination reaction. Here 2 or more reactant combine to form a single product. Combination reaction with an example. Here 2 or more reactant combines to give a single product. Let us take that example here, burning of coal. Coal is a carbon compound. Carbon combines with oxygen will give you carbon dioxide gas. So you can see here two reactant combines to give you a single product. Okay, that is combination of two reactant and you got a single product. Similarly, you can take one more example, formation of water here, that is H2 hydrogen plus oxygen will give you H2O, that is two reactant combines to give a single product. So in short, I can explain the combination reaction as here two or more reactant combines to give a single product. So in this two examples, we have two reactant combines to give a single product. So in short, it is explained as two or more reactant combines to give a single product. Okay, here the single product is carbon dioxide, over here the single product is water. Let us see the second type of reaction, decomposition reaction. A single reactant breaks down to give two or more products. Decomposition reactions are three types, that is thermal decomposition occur with the help of heat, that is then you have photochemical decomposition occur with the help of light, and third one is electrical, that is decomposition occurs with the help of electricity. Let us see each one of them. Okay, that is, let us see the first one, thermal decomposition. Okay, calcium carbonate on heating it decomposes into calcium oxide and carbon dioxide. Calcium carbonate on heat, okay, you will decompose into calcium oxide and carbon dioxide. This is called thermal decomposition because decomposition occurs with the help of heat. Okay, a single reactant breaks down into two or more products. Here calcium carbonate broke down into two products. Okay, calcium carbonate is called limestone and your calcium oxide is called quicklime. Okay, it is a quicklime. A single reactant breaks down into two or more products. Here two products, okay, with the help of heat, hence it is called thermal decomposition. It is called thermal decomposition. Okay, now let us see one more decomposition, that is called photochemical decomposition. Decomposition occurs with the help of sunlight. You may have seen that white silver turns grey in sunlight. Okay, this is decomposition of silver chloride into silver and chlorine, that is C. Silver chloride decompose into silver and chlorine. Okay, that is white silver turns to grey in sunlight, that is decompose into silver and chlorine, okay, with the help of sunlight, hence it is called photochemical decomposition. Okay, you can take one more example, in silver bromide also behave the same, decompose into silver and bromine. Again, this is also with the help of sunlight. This is, okay, decomposition reaction, that is with the help of sunlight, then it is called photochemical decomposition. Here both these reactant breaks down into two or more products, two products here with the help of sunlight, hence it is called photochemical decomposition. Let us see the last type of decomposition, that is electrical decomposition, that is water decompose into hydrogen and oxygen with the help of electricity, that is electricity. With the help of electricity, it decomposes into water and oxygen. This is electrical decomposition. So decomposition to occur, either heat is required or sunlight or electricity is required. Here single product, all these cases single reactant breaks down into two or more products. Here in all these examples it broke down into two products, but a single reactant, if it break down into two or more products, then it is called a decomposition reaction. Okay, it is exactly opposite of combination. Combination says that a single product is formed from two or more reactant. Here one reactant breaks down into two or more products. Okay, let us see the next type of reaction, displacement reaction. Here more reactive element will displace a less reactive one from a solution of one of its compounds. Let us take the example for the displacement reaction. Here we have iron combines with the copper sulfate and gives you iron sulfate and copper. Here iron is more reactive, it displaces its copper from its compound. Copper was initially with the SO4 sulfate. Now iron combines with the sulfate and give you iron sulfate, and copper is left behind. Okay, it displaces more reactive element, displace the less reactive is just copper. Here it displaces the copper from its compound. See, iron combines with sulfate and becomes iron sulfate, and copper is left behind. Okay, Similarly, I can take one more example, zinc and copper sulfate, okay, and becomes, say, zinc sulfate, and which is left behind here, copper is left behind, okay. Zinc is more reactive element, displace the less reactive one is copper from its compound. Copper with the copper was copper sulfate with this compound, okay. Now it is replaces, now copper is left behind. Imagine, simple, how to remember it is, imagine you and your friend, okay, some enemy came and they became friend. Now zinc and sulfate become friend and you are left behind. That is more reactive element and replace a less reactive one, it's from compound, okay. Now which is more reactive, which is less reactive, you can see in the reactivity series. Reactivity with the series will help you to find out the which is more reactive and which is less reactive. I repeat again, in displacement reaction, more reactive element displace the less reactive element from its compound. That is, zinc becomes zinc sulfate and copper is left behind because copper is less reactive, okay. Let us see the last one, double displacement reaction, where exchange of ion takes place. Let us see double displacement reaction with an example. Sodium chloride combines with silver nitrate, that is AgNO3, will give you silver chloride and sodium nitrate, NaNO3. So here clearly you can see here, sodium chloride combines with silver nitrate gives you silver chloride and sodium nitrate. Here again sodium and nitrate are exchange of ion takes place. Initially sodium with the chlorine, now it combines, becomes sodium nitrate. Can you see the sodium nitrate over here? Similarly, silver with the nitrate, now it becomes silver with the chlorine, that is AgCl, okay, that is silver chloride. Let's take one more example. You can take here barium chloride combines with H2SO4 sulfuric acid and becomes here, its ions get exchange, barium becomes barium sulfate, and here HCl, here HCl, see, HCl, hydrochloric acid, okay. This is where exchange of ion takes place. Here exchange of ion takes place, okay. Initially, so barium chloride was a barium, now barium becomes barium sulfate, hydrogen chlorine, hydrogen becomes hydrogen chloride, okay. So exchange of ion takes place, you can notice here. One more example you can take here, one more example I can give you. Sodium sulfate combines with barium chloride, BaCl2, will give you now what? Tell me, exchange of ion. Sodium chloride and barium sulfate. Here exchange of ion takes place, okay. Initially they stay, you and your friend, somebody, these two are friends, now you become, your friend becomes his friend and his friend becomes your friend. It is like this, NaCl and BaSO4, okay. So exchange of ion takes place, you can clearly notice that here it becomes like this, and these become friends and these become friends, okay. Exchange of ion takes place, okay. So double displacement reaction is nothing but here exchange of ion takes place. Last reaction forms a precipitation, okay. This is precipitation, forms a precipitation. Precipitation is nothing but an insoluble substance. It produces an insoluble substance.